Welcome to online lecture series in organic chemistry, and we are discussing about the extraction of copper from copper pyrites. In earlier video we have seen the smelting. Smelting produces the copper matte or white metal, that is Cu2s. In this video we are going to discuss the Bessemerization. Bessemerization, in this stage actually the copper matte it is converted into blister copper or copper metal by self-reduction process. Now since there is no external reducing agent used, this process is also called as autoreduction process. Now here in this process actually the molten copper matte containing ferrous sulfide impurities, that is Cu2s plus Fes, it is poured into Bessemer converter and a stream of air it is passed through molten Cu2s, that is copper matte, from one side of the converter. Now here actually as soon as air is passed through Bessemer converter, the ferrous sulfide it is converted into ferrous oxide at high temperature, which further reacts with silica, which is added as a flux, and the ferrous sulfide it is converted into ferrous silicate in the form of slag. This reaction is exothermic, and detailed about this reaction it is explained during smelting operation in earlier video. At the same time, whatever copper oxide is there, that copper oxide reacts with ferrous sulfide and there is a formation of cuprous sulfide and ferrous oxide by this reaction. Whatever unreacted cuprous oxide is there, it reacts with ferrous sulfide and there is a formation of cuprous sulfide, that is white matte, or it's a copper matte and or white metal and ferrous oxide. This reaction is exothermic. So this is the Bessemer converter. So this molten matte it is taken in this converter and hot air it is passed through this side pipe, and the temperature of this Bessemer converter it is maintained around 1573 Kelvin to 1673 Kelvin. So at high temperature the cuprous oxide, first of all it combines with rest of the cuprous sulfide and there is a formation of metallic copper. So the reactions involved are, so this cuprous sulfide first of all combines with oxygen and there is a formation of cuprous oxide. This reaction is also exothermic. Now this cuprous sulfide, the remaining cuprous sulfide reacts with cuprous oxide and there is a formation of copper. There is a reduction of cuprous oxide to copper and there is a evolution of SO2 gas. So here when the flame issuing from the converter appears to become a green, there is an indication that self-reduction of cuprous sulfide is over. When this flame in this Bessemer converter it appears green, then that is the indication of completion of reduction process. The air blast is then stopped and the molten copper it is poured into the molds. Now as the copper solidifies, sulfur dioxide gas which is formed as a byproduct escape out from the reaction mixture, giving the copper, and that copper appears like a blister and therefore it is called as blister copper. The product has a composition, that copper has a composition of 97 to 99% copper and 1 to 3% impurities of iron, nickel, arsenic, antimony, bismuth, silver, gold, platinum, etc. The blister copper, it is further refined. So composition of blister copper is 97 to 99% copper and 1 to 3% impurities of other metals like iron, nickel, arsenic, antimony, bismuth, silver, gold, platinum, etc. Now, what is the physico-chemical principle involved in Bessemerization? Bessemerization process, it is carried out at 1573 to 1673 Kelvin. Now here during the Bessemerization, the reduction of cuprous sulfide is carried out by self reduction, where cuprous oxide is formed which interacts with unreacted cuprous sulfide, forming metallic copper and gives the sulfur dioxide gas. Now you can see, as temperature increases because of exothermicity of the reaction, as temperature increases, the partial pressure of sulfur dioxide also increases, and at 1673 Kelvin the partial pressure of sulfur dioxide, it is approximately equal to 1 atmosphere. And when partial pressure of sulfur dioxide reaches to 1 atmosphere, the mutual reduction of cuprous sulfide and cuprous oxide becomes fast, and hence the temperature is maintained about 1573 to 1673 Kelvin. So this is about Bessemerization. This process is very easy. The copper matte, molten copper matte, it is heated in Bessemer converter using air, and first of all ferrous sulfide is removed in the form of slag. First of all it reacts with cuprous oxide and there is a formation of cuprous sulfide. Then the ferrous sulfide also, all of this ferrous oxide reacts with the flux, that is silica, and there is a formation of slag, and these are the reactions involved during Bessemerization. Now next step is refining of blister copper. Refining is done by two methods, poling or fire refining. First method is poling or fire refining. Here the blister copper, it is melted in reverberatory furnace and stirred with the poles of green wood or logs of the green wood. The heated wood gives the reducing agent, that is hydrocarbon, which reduces oxides of copper formed into copper metal. So sometimes still some copper oxide is remaining in the blister copper, which is converted into metal copper. So this cuprous oxide reacts with hydrocarbon, which is formed from the green logs of wood at high temperature, and it reduces cuprous oxide to copper. This is the poling or fire refining method. And another method is electro refining. If the copper is to be used for conductivity work, then it must be in a extra purity, or its purity must be very high. So during refining, actually this electrolytic bath is taken. Here the pure copper plates, these are taken as a cathodes, and impure copper, that is blister copper, these are used as a anodes, and the mixture of copper sulfate solution and sulfuric acid, it is used as electrolyte. Normally 3% copper sulfate and 15% sulfuric acid, this mixture, it is used as an electrolyte. Now here the aqueous copper sulfate solution acidified with sulfuric acid, as it is used as an electrolyte, as soon as current is passed through this or between the anode and cathode, there is a oxidation at anode, and during oxidation reaction there is a metallic copper, it is converted into cuprous ion, plus there is a loss of electrons. These cupric ions enter into the electrolyte, which are further migrated to cathode, and at cathode there is a reduction reaction. Cupric ions gains 2 electrons and there is a formation of metallic copper, which is deposited on the surface of cathode. So in this way size of cathode increases and size of anode decreases. So anode dissolve into the electrolyte and size of cathode increases. And actually there is a transfer of pure copper from anode to cathode, while metal impurities like zinc, nickel, lead, iron, which are more basic than copper, pass into the solution as a sulfates and not discharged at cathode. Okay, and sometimes when the blister copper contains the noble metals like gold, silver, platinum, then these noble metal impurities, these are not affected by electrolytic solution of copper sulfate and sulfuric acid, which settle down as a anode mud, and these are further recovered by the other metallurgical technique. In this way, by electrolysis or by electrolytic refining, 99.95% pure copper is obtained. So this is what is electro refining. So summary of this point is, in electro refining, the electrolytic cell is used, which contain 3% copper sulfate and 15% sulfuric acid as a electrolytic solution. The blister copper, that is impure copper blocks, these are used as a anodes, and pure copper plates act as a cathode. As soon as current is passed, direct current is passed, oxidation occurs at anode and anode gets dissolved into the electrolyte by this oxidation reaction. Cu gives Cu2 plus 2 electrons. Cu2 plus ions migrate towards cathode, and at cathode there is a reduction of Cu2 plus ion and there is a deposition of pure copper metal on the surface of cathode. So this is what is electro refining.